Okay, shapes of molecule question. So ammonia reacts with aluminium chloride as shown by the equation. Draw diagrams to illustrate the ammonia molecule and the aluminium chloride molecule. Include diagrams. Include in your diagrams lone pairs that influence the shape, and we need to do the bond angles as well. Very often people will draw this ionically. It is not ionic. The clue here is the word molecules, which is telling you it is covalent, i.e. simple molecular, macromolecular. Okay, so make sure that you are drawing these as covalent molecules. So let's start with ammonia. So we're going to use the valence shell electron pair repulsion theory to calculate this. So nitrogen is in group 5. Hydrogen has 1 electron in its outer shell, and there are 3 of them, which means in the outer shell of nitrogen there's going to be 8 electrons. Of course, these need to be in pairs. So that's going to be 4 pairs around here. Now with the 4 pairs, 3 are bonding pairs, which basically means one of those 4 pairs is a lone pair. So start with my nitrogen, put my lone pair on here, and then put my hydrogens on here. So I've included my lone pair. I need the bond angle on here as well. So the shape of this would normally be tetrahedral with 109.5, but the lone pair reduces it by 2.5, which gives you 107 degrees. So that's the ammonia done. So with aluminium chloride, same thing as what we've just done. So aluminium is in group 3, so it has 3 electrons in its outer shell. Chlorine has 1 electron that it uses for covalent bonds, and there are 3 of them, which means in the outer shell of aluminium there will be 6 electrons as 3 pairs. I have 3 single covalent bonded chlorines on there, so they're all bonding pairs here, which means that the shape of this is going to be trigonal planar. So chlorine, 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 and the bond angle here then is going to be 120 degrees. So 1 mark for each correctly drawn diagram and 1 mark for both bond angles being drawn correctly. Okay. So name the type of bond formed between the N in the ammonia and the aluminium in the aluminium chloride. So this is going to be a dative covalent bond. And again, if we just go back to the previous diagram, and I'll highlight this in a slightly different colour. Let's highlight this in yellow. So this lone pair here is going to form a dative covalent bond with aluminium in its vacant position, really. Remember, aluminium can have 8 electrons or 4 pairs around its central atom here. So it's going to occupy one of the gaps there. Okay, so let's go back to this. So a dative covalent bond, remember this is where both electrons in the covalent bond are donated by nitrogen. And then explain how the value of the chlorine-aluminium-chlorine bond angle changes on the formation of this. So aluminium chloride has 3 pairs, but if I draw that as a dative covalent bond onto the aluminium chloride, so this now has 4 pairs. So I'm basically going from trigonal planar to tetrahedral. Now trigonal planar has a bond angle of 120 and tetrahedral has a bond angle of 109.5 degrees. So we're moving from 3 pairs to 4 pairs, or you could say it is going from trigonal planar to tetrahedral. Therefore, the bond angle decreases from 120 degrees to 109.5 degrees.